Hello friends, now we will see the different components of current in semiconductors. In case of conductors, that is pure metals, we have only one type of current, that is known as drift current. Why? Because in case of conducting materials, that is metals, all the charge carriers are free. If all the charge carriers are free, they are uniformly distributed in the bulk of the material. If these are uniformly distributed in the bulk of the material, so there is no question of concentration gradient inside the metals. All the charges are uniformly distributed. So if there is no concentration gradient, so there is no question of diffusion current in case of metals. So the flow of charge carriers in metals is only because of the potential gradient, that is nothing but electric field. When you apply electric field across the ends of a conducting material, then the electrons inside the material will flow from higher potential to lower potential under the influence of electric field. So that current is known as drift current. But in case of semiconductors, we have two possibilities. One is we have free electrons in conduction band and holes in valence band. So these electrons in conduction band and holes in valence band can flow under two conditions. One is you apply electric field across the semiconductor bar. When you apply electric field across the semiconductor bar, then the flow of charge carriers, that is electrons and holes both, will be nothing but because of that potential gradient, because of electric field applied across the semiconductor. So that component of current is known as drift current. So drift current in semiconductors is nothing but that is flow of charge carriers under the influence of electric field, and the drift current because of electrons, this is drift current because given by the sigma conductivity into electric field, that is nothing but drift current because of electrons, and this is equal to concentration of electrons Q into mu n multiplied by E. Remember, I am talking about drift current because of electrons, so I have to take conductivity because of electrons only. So that is why I have taken this component of conductivity, not conductivity due to holes. Now the second component of the current density is because of holes, so that is drift current because of holes. So that is equal to sigma, this was because of electron, this is sigma because of holes, and that is nothing but P Q mu P into electric field. So that is drift current because of holes. Now we have just discussed in my previous video, that was diffusion current, and I have explained the diffusion is nothing but flow of charge carriers from higher concentration to lower concentration. The flow of charge carriers from higher concentration to lower concentration is nothing but diffusion, and that constitutes a current. That current is known as diffusion current. So of course the semiconductors have both type of charge carriers, so there has to be current because of the electrons. So this is J N diffusion, this is equal to NQ dN by dx, this is N dN, I'm sorry, this is, I'm repeating, that was a mistake. So J diffusion is equal to Q dN dN by dx. dN is nothing but diffusion constant. So dN is known as diffusion constant of what? Diffusion constant of electrons. And what is dN by dx? That is concentration gradient of electrons. So then diffusion current because of holes is given by minus Q dP by dx. So similar to this expression, dP is diffusion constant because of holes, dP by dx is nothing but concentration gradient of holes. Why do we have negative charge? Negative charge is because the holes will flow from higher concentration to lower concentration. So if holes are flowing from higher concentration to lower concentration, that means there is negative concentration gradient in the direction of flow of holes, and current is flowing in the direction of flow of holes. So that means the current is flowing in the direction which is having negative concentration gradient of holes. So that is why it is negative. So there are 4 components of current in semiconductors: drift current due to electrons, drift current due to holes, diffusion current due to electrons, and diffusion current due to holes. Now if you talk about that is electron current, so electron current in total can be written like Jn is equal to Jn drift plus Jn diffusion, and that is equal to nothing but Nq mu n E plus N dn by dx. That is your total current because of electrons. Now the total current due to holes, so that is nothing but Jp is equal to, that is Jp drift plus Jp diffusion, and this is equal to Pq mu p into E plus P dP dn by dx. This is minus, not plus. Why? Because diffusion current due to holes is negative. So this is nothing but total current density. J is current density, it is not current, rather the current density. So these are important expressions you should remember, and you have lot of numericals in GATE from this topic, and lot of questions in engineering service prelims and mains as well. So this is important topic from examination point of view. You just need to remember these hardly 4 formulas, and there is always possibility of question from this part of the topic. Now we will see the different questions from this topic. Now let us see the questions on components of currents in semiconductors. The first question is: the electron concentration in a sample of uniformly doped n-type silicon at 300 K is 2.25 into 10 raised to power 15 per centimeter cube. If the charge of electron is 1.6 into 10 to the power minus 19 coulomb and the diffusion constant dn is equal to 35 centimeter square per second, the current density in the silicon if no electric field is present is. You have to find the current density. So you are given the electron concentration, you are given diffusion constant and charge of the electron. So here the semiconductor is uniformly doped, so there is no concentration gradient. So if there is no concentration gradient, then dn by delta n by delta x is 0, number 1. So diffusion current density must be 0 because delta n by delta x is 0. Then if there is no electric field present in the semiconductor, then the drift current velocity, which is nothing but function of E only, sigma into E, is also 0. Sigma E, basically the drift current density is what? Sigma into E, and that is equal to 0. Why 0? Because electric field applied is 0. If electric field applied is 0, then your drift current density must be 0. So J equal to sigma E is also 0. So total current density must be equal to 0. That was question in 2003 in GATE, 2 marks question. Then under low level injection assumption, the injected minority carrier current of extrinsic semiconductor is essentially. Here you have to see the minority carrier conductor under low level injection. So when there is low level injection means we have just seen when you illuminate one end of the semiconductor, there is a diffusion, there is a concentration gradient. Why? Because at the point of illumination there is generation of electron hole pairs. So these generation of electron hole pairs will result in diffusion of the carrier. So under low level injection, the injected minority carrier current for an extrinsic semiconductor is essentially diffusion current because of the concentration gradient because of illumination. So let us see the next question. The statement of for linked answer question. These are linked answer question which were before 2010. Now it is no, this type of question are no more in GATE. The silicon sample with unit cross sectional area shown below is in thermal equilibrium. It is in thermal equilibrium. The following information is given. At 300 Kelvin, the electronic charge is given to you. The thermal voltage is 26 millivolt. Electron mobility is 1350 centimeter square per volt second. You have to find the magnitude of electric field. So you are given this semiconductor bar. Electric field is what? Electric field is nothing but V by L. V is voltage across the semiconductor bar, L is length, so L is given to you, that is 1 micrometer. Voltage is given to, that is 1 volt. So you get the electric field across the semiconductor bar. Then magnitude of electron drift current. So you have to find electron drift current, and you know what is electron drift current? That is J equal to sigma into E. Sigma is conductivity, that is given by this. Since it is N-type semiconductor bar, so N is almost equal to ND. So you get conductivity of the material, and from the conductivity, electric field is you already calculated in the previous question. So you get the current density J, that is equal to sigma into E. So that is how you solve the question. This was in 2010. Now let us see the next question. The drift current in semiconductor depends upon, you know what is drift current? That is sigma into E. So option A only electric field, option B only carrier concentration, option C both electric field and carrier concentration, option D both electric field and carrier concentration gradient. So drift current does not depend on the carrier concentration gradient, rather that depends on the concentration gradient. It is very much evident from this equation. Now let us see the next question. Assume electronic charge Q is equal to 1.6 into 10 to the power minus 19 coulomb. KT by Q is 26 millivolt. Electron mobility is given to you, that is 1000 centimeter square per volt second. If the concentration gradient of electrons injected into p-type silicon sample is 1 into 10 to the power 21 centimeter cube, the magnitude of electron diffusion current. You know what is the here KT by Q is given. What is diffusion current? J is equal to Q into dn by dx, but diffusion constant is not given. You are given KT by Q, that is KT by Q. So if KT by Q is given, you know dn upon mu n, so you get dn from this relationship. So this is KT by Q. So here from this what we get? We get dn, and you put the relationship into this equation. Dn is obtained from here, Q is already given to you, dn by dx is already given to you. So by putting this relationship here, you get Jn. So that is how we get the diffusion current density. Then at 300 K, the whole mobility of semiconductor is given by this, and KT by Q is this, the whole diffusion. Basically this is question on your Einstein relationship. So you are given mu and KT by Q, and we know Einstein relationship, that is dP by mu is equal to KT by Q. So you get diffusion constant directly by using the Einstein relationship. Then there seems to be some problem in this question. We will discuss it later. Then next question is the dependence of drift velocity of electron on electric field in a semiconductor is shown below. You are given drift velocity as a function of electric field. The semiconductor has a uniform electron concentration of this. Electronic charge is given to you. If bias voltage is 5 volt applied across 1 micrometer region of the semiconductor, the resulting current density is, you have to find the current density. You know what is the here, to find the current density, first of all, when electric field is applied, so current density is what? Sigma into E. So if you see the relationship, this is what you have to find, sigma into E, and sigma into E is what? N E mu N into E. Here mu n is not given to you, and concentration is given, that is what. So to calculate mu, first of all, then electric field is given to you, that is in the form of the curve. So what I will do, you know what is the length? 1 meter. Voltage is given to you, that is what? 5 volt. Length is given to you. Electric field is what? V by L. So voltage across the semiconductor bar is given. length of the semiconductor is given, so we get V by L equal to E. So we have got one parameter required for calculation of current density, that is E. For calculation of sigma, I need to know mu n. So let us see how to find mu n. So mu n is what? Your drift velocity is mu n into E. E we have already calculated. Drift velocity can be obtained from here. E is 5 into 10 power this. So from here you get drift velocity, and that is nothing but slope. So here from the slope of this you get the mobility. Why? Because mu n is Vd upon E. The slope of this curve is Vd upon E. So that is nothing but mobility. And slope of the curve is what? You can see that is 10 power 7 divided by this, that is slope of this curve, that is mobility of the electron. So you get the mobility. So by putting the relation n E mu n, which is calculated above, E we have already obtained V by L, so you get current density. So these were the questions which appeared from the components of current in past. So, and I have covered almost all the questions which have appeared in past, except one or two where there was a problem. I need to see it at later stage. So I hope your concept and formulas and the different types of questions which have appeared in the exam are clear. But I just have one request: if you really finding these videos helpful to you, please do share with your friends so that they can also get benefit out of it. Thank you very much.